Hello everyone. So today we're gonna introduce our project, which is CartScout. So we're trying to focus on a very fundamental problem of web browsing. That is, usually when we're looking for like something on the internet, we do a Google search, maybe on Amazon or Target or a preferred vendor, and then essentially if there's something out of stock or something's not super relevant, we really have to go through multiple websites. So we're building improving self-improving agents, browser agents, which can do the task for you. So you just hit the product that you want. For example, right now I'm looking for AAA batteries under $10, right? And then what it does is goes through, there's a typical problem that you see is you might not find the most relevant things right away, right? So that's where CartScout comes in. So we built self-improving browser agents without the frontier model burn, right? So if we use frontier models, we have a big build go and end up scraping every single HTML component, the DOM components, and that adds up to tokens, right? Here we can see that as context loads increases, so even the frontier models, the accuracy wall slowly goes down, and with like really high context load, the accuracy is like 61% with super high context burn. So we're trying to fix that by using smaller models, smallest like Qwen3, which are like orders of magnitude smaller than these frontier models, and we're able to use that to basically find did like reinforcement learning based tuning to improve that. And here we're just also having like our own compression memory. So basically this is like a custom layer that we've added before the context from the scraped website is passed on to the LLM. So if you do like a higher compression, we have like lower things retained in the task state. So by changing the compression magnitude, we're able to pass how much context can go to the LLM. And this again helps us improve the context that we're sending to the LLM. Now, if coming to the self-improving part, every rollout that you see is training data. It's not just a pass or fail, but essentially the moment you click on something and it doesn't do what you want it to do, it can become like a data point, and the agent gets like fine-tuned on it, and then again you come up with like a better model at the end of the day. So we can see like the live demo of the actual browser rollout. So in order to get some computation advantages, we've taken like a screenshot every 3 seconds, so it's not like a very fluid video. So you can begin here, and then you say, for example, AA batteries, right? So you click on it, and then you see it's going to Amazon, and then it's looking at the target one, where it's not available, and now it's again going back to Amazon, looking at the description, and then finding it. So, and then essentially it goes to checkout. So this is what we've automated. And there's one more example where you can see that it's a cutting board, and then we don't find it on Target. And we did actually, and then it goes through the website, and then it makes sure that it clicks on the object and makes sure that the descriptions match. So there's one interesting that we've been able to build. And finally, we have the training part, right? So we can see that we've seen like even though it's like a very small, we worked with like around 300 episodes. That's how many data points we had, and then a few more based on some synthetic data. And then we can see that we've gotten like significantly closer to what frontier models offer, and that to like orders of magnitude smaller models, and we're able to improve get close to like 0.7 in terms of the reward mean. So here we can see different metrics, and then we can see as we have like better and more clear constraints, the reward keeps on increasing as our training progresses. So we're able to get a pretty good accuracy, and essentially the core part of it is that the model did really work, and then as users keep using these, we get more and more data points, so we don't even have to worry about the data set not being good enough, but rather it improves on the go. So essentially, it's kind of like an online learning paradigm. And then yeah, that's about it. And then we have like the reports, which have like the details, traces, and stacks. Thank you.